Hi, this is Kevin Trainer. Welcome to my lecture on activity diagrams and activity diagramming. Activity diagrams are a very popular tool that are part of the Unified Modeling Language, the UML. And when it comes to showing program logic, business process flow, all that kind of stuff. They're very, very popular, and they are something that we're going to use in at least one way in our systems analysis course, with the option of using them in some other ways if you're interested. Okay, so first, I want to take a stroll through the slides from the textbook. Chapter 7, Appendix B is about activity diagramming, and it's kind of brief. It tries to roll a lot into into 3 or 4 pages. And I think it's sort of overly ambitious there. The other reading that I've recommended from you is from IBM Developer Works, and that's, I think, a better reading because it doesn't try to do too much all at one time, and I probably like that reading a little bit better. And we'll talk about that in a couple of minutes. So, activity diagrams show the conditional logic for the sequence of system activities needed to accomplish a business process. And when we say system here, we mean a system with a small s, so not our system with a capital S like we talk about in our use case specifications, but the combination of human activities and automated activities that get the job done in a business process. It's a pretty expressive diagramming language where we can show activities going on in parallel with each other, which is pretty powerful. We can show alternative behaviors. We can show choice and selection. The primary use that we're going to make of activity diagrams is as a way to illustrate the logic of a particular scenario in a use case specification. Okay, so you can use activity diagrams for quite a lot, but what we're going to use it for is just that, illustrating the logic of a particular scenario within a use case specification. But you can use activity diagrams to depict the flow of control from activity to activity, help in use case analysis to understand what actions need to take place, help in identifying extensions to use cases, although we're not using extend, but you might recall that an alternative to extending a use case is to insert an alternative flow into the use case. Model workflow, which is typically one word, workflow, in business processes. Model the sequential and concurrent steps in a computation process. So we can even use activity diagrams to illustrate the logic in a set of business rules, for instance. Okay. So here on slide 5, we're showing a pretty big activity diagram that's using a whole lot of the features all at one time. So we jump right in, and we'll go back and we'll talk about the individual parts. Okay, so don't fear that we're going to lose you here by jumping into the full picture. So what we have here is not, in fact, a use of activity diagrams to illustrate a scenario in a use case. Okay, because a scenario in a use case is a little more limited kind of a diagram than this. Instead, this is using activity diagrams as a more general systems analysis tool for the systems analyst to work with the users or other stakeholders to understand the flow of information and material and activity in a business process. Okay? So, for instance, we, meaning our class, a couple of weeks ago, we studied a little bit of data flow diagramming and the context diagram. And I may have mentioned at the time that data flow diagramming was kind of taken over by business consultants, management consultants, people who wanted to come into organization and understand business process flow and make improvements in it. Well, it turns out that this activity diagramming has some of the same kind of attractive features. So there are people who use activity diagrams to show the flow of activity in an organization to get a business process done. And this is something a systems analyst can use when working with the stakeholders to kind of understand the big picture. Activities that involve the use of the automated solution and activities that don't. So this particular picture is not limited to understanding the automated solution, and this is more the kind that a systems analyst might use to get an understanding of the big picture when talking to the stakeholders. These lanes that we see here are an interesting feature of activity diagrams. They're called swim lanes because they represent, because they look like the swim lanes on the bottom of a lap pool. Okay, that's how they got that name. And they, just like the swim lanes that we paint on the bottom of a lap pool, are meant to kind of divide the traffic to keep things from colliding from each other, so we know who belongs in which lane. Well, they serve the same kind of function for activity diagrams. So the typical thing is we pick some functional area within the business, or it could even be a physical area, some kind of building where things go on, like the accounting department or customer service department or fulfillment department or purchasing department. In some traditional companies, these things might be located in different physical parts of the premises. But more likely, we're just talking about activities that are within the control of a certain part of the organization. So it's not surprising that in activity diagrams, the rectangles, in these cases we're drawing them with rounded corners, the rectangles represent activities. So in the relationship between the activities and the swim lanes is that when you place an activity in a particular lane, you're saying that, to your understanding, this activity is part of that part of the organization. So we're saying that we're going to receive an order in the customer service part of the organization. We're going to prepare an invoice in the accounting part of the organization. We're going to pull available inventory in the fulfillment part of the organization. We're going to prepare a back order in the purchasing part of the organization. Okay? Those are the swim lanes and the boxes, if you want to call them that. Now the boxes are connected to each other with these flow lines, and the flow lines have to do with the sequence of activities. Generally speaking, we go in the direction of the arrowheads, and typically when we draw these, flow lines go down, right? There's a tradition in maybe more traditional programmer flowcharts of not being too concerned about having the direction of action go either up or down. We do a lot to kind of cram things onto the paper, but generally speaking, in activity diagrams, the flow of action goes from the top to the bottom. So that's the way you see it happening here. It occasionally will loop back. Okay, so we're saying that we're going to receive the order before we're going to pull available inventory and prepare the invoice. We have some interesting little connectors within the flow lines. This particular one is what we call a fork, and we'll go through that in a little while. But what a fork says is we're going to do more than one thing at the same time. And this is very, very powerful and expressive in that we show that it's possible to be doing, in our business process, it's possible to be doing two or more activities at the same time in parallel with each other. Now, in traditional computer programming flowcharting languages, this was now possible to express, and in fact, in sort of old style computers, it was very it was impossible to have the computer working on two things at the exact same time. Sometimes they appeared to be being done at the exact same time. And so early flowcharting languages didn't do a good job of showing this parallel behavior. And this is a flowcharting language that does a great job of that. And in fact, in computing these days, we often have things where with multiple processors, we're doing things at the same time. And in the business world these days, we have a lot of processes that we try to do at the same time in order to speed the overall process up. So we have a fork, that's that line there, okay? And down at the bottom where we begin to do things concurrently at the same time before, we have a thing called a join. So this is another line where the lines of control come back. So it's possible on an activity diagram to have more than one of the part of the process going on at the same time, and that's what we've done here with this fork and join. So we've got kind of two sides to it at this point, and they're going on at the same time. We have another kind of connector feature, and that has to do with the decision logic. And we have these diamonds that are branch and merge. Okay, so the diamond typically says either a decision is about to happen, okay, or actually we're going to say a decision is happening, not about to happen, or we're saying we've finished with the decision and we are going to merge together again to get one line of execution. So this top diamond up here is a branch, and the one down here is a merge. Here's where the two sides come together. Unlike the fork, the branch only results in one line of execution. So we come to a branch and we either go one way or we go another way, but we can't go both ways at the same time like we can with the fork. And I also want to point out with the fork, we can do two things at the same time, three things at the same time, 20 things at the same time. We can do a lot of things at the same time. But with branches, we're making decisions. We're not trying to do things in parallel with each other. And we either go one way or we go the other. Okay, how do we know which way we're going? Well, we have these things you see in this slide here. We have in square brackets missing some items. Okay. This is called what we call a guard condition. You can think of it as guarding that path of flow. Okay, so we come to a decision and it has to be true that we're missing some items in order to go down that path. Now, in this case, we don't have a guard condition on the other path. And for my style of diagramming, that's an error. Okay, so I want to see a guard condition on every path. Whoever was the author of this particular diagram thought, well, if we go down one path, we're missing some items, and if we're not, then we go down the other path. Well, that's kind of lazy. We ought to have a guard condition on each of the paths. Eventually, we come back to a point where we merge, even if it's the very end of the process, okay? And now, how can you tell that we're at a merge instead of a branch? Well, you can usually tell by the arrowheads of the flow lines that are going into it. Okay, so we have a diamond here that has a bunch of arrowheads going into it, so that's a merge. We have a diamond up higher that, well, they have arrowheads. Well, we have one arrowhead going in and the other arrowhead going out. So one in, multiple out. And on the merge, we've got multiple in, one out. And the other thing is on the outflows in a merge, we don't have a guard condition. Okay, because there's no decision being made. Whereas on the outflows on a branch, we should have a guard condition on each of the branches. Okay, now one of the interesting things here is that we merge, we come to pullback order inventory, then we come into a merge, and then whichever way we had gone on the decision, we do a send order, and then we have another decision, another branch. Okay, so we say request express, so I guess they requested express shipping, and here they've said else. Okay, that's fine. Okay, we have another guard condition. It's sort of relative to its siblings. Okay, that's fine. Okay, so we either do one or we do the other, and then of course we merge again. So this is how this goes. Now, why is this not your typical activity diagram for a use case scenario? Well, in a use case scenario, we don't have this many players. Okay? And we specifically were saying what's being done in the automated system and what's not. And I'll show you an example of one of those style of diagrams in just a minute. So what we have here is just a general activity diagram that somebody would use as an aid to getting the big picture when they're being a systems analyst. Okay, so it's a communication tool. Oh, sorry, I went too far. Okay, so why don't we back down on this and get this back to a decent size. All right, and then let's take a look at an activity diagram. Let's take a look at one that is of the style that I'm talking about. Okay, And this is what I call the ship order. Well, sorry. So for our practice case, our practice case scenario, um, part of the system that I laid out back when we were laying out the use cases is I had a use case for ship order. Okay. And in the use case for ship order, you can imagine that I had a basic flow in the specification, and then I had alternate flows. Okay. Now, what I'm doing here is I'm creating an activity diagram for the scenario where we only do the basic flow. I realize that's not really razzle-dazzle, but we're trying to concentrate on the diagramming. Okay? So we're coming into the basic flow. We see another symbol here. We haven't seen that, haven't really talked about it before. This filled in circle is a start symbol. Okay, so that's how we know where we start. All right, we've got 3 swim lanes. Now, in our kind of activity diagram that we're using to illustrate a use case scenario, we're always going to have a column for system. Okay? This is going to represent the action taken by the automated system in the system. Okay? Well, what other columns will we have? What other swim lanes are we going to have? We'll have a swim lane for every other actor, for every actor who interacts with the system. So here I have a scenario that I'm showing where I've got 2 actors that are interacting with the system in the activity diagram for ship order basic flow. Okay? And it turns out it works out well to put the swim lane for system in the middle because of the fact that in our way of looking at the world, we're only interested in interactions that are moderated by the system. And if you remember back when we learned to write these flow narratives in the use case specification, we talked about them kind of looking like a tennis game. Actor, system, actor, system. Okay? It doesn't always have to be the same actor. So if you put the system in the middle, it's in a perfect place to be in the middle of a tennis game. For those of you who play tennis, think of the system as playing a game of Canadian doubles. So they're the single, and they're playing against 2 other people. So a little too tennisy there. Sorry about that. So the first activity, the order shipper, okay, that's one of our actors from the use case diagram, the use case specification, signals ready to ship orders. Next, the system displays orders awaiting shipping. Now, I just want to emphasize that the flow of activity here should match exactly what it says in the use case specification. Okay, these are 2 expressions of the same facts. Okay, now they can be worded a little differently because we have titles at the top of each of the swim lanes. So we don't have to say the system displays orders awaiting shipping because we know who the subject of the sentence is because it's in the system swim lane. So we can just shorten it up and say display orders awaiting shipping. Okay? Over here, Likewise, we don't have to say order shipper signals ready to ship orders. Instead, we can just say signals ready to ship orders and the subject order shipper is inferred. Now let's look at the flow of the action here. Doesn't it look like a tennis match? Okay. Order shipper, system, order shipper, system, order shipper. Now, sometimes the actor or the system might do a couple things in a row that you want to call out. That's okay. When we say it's like a tennis game, we don't mean that we can express everything that's done on one side of the net in one sentence or one box. Sometimes they do a couple things in a row. Okay? So in this case, the order shipper does choose order to ship. The system print packing documents, and then the order shipper place merchandise and documents in box. Weigh box, enter shipment information including weight into USPS web application. You'll remember that the version that I was doing in this particular round of diagrams that I've done shows that we don't have an automated interface to the USPS information system, so we're going to have to interact with it. Okay, it's okay to show this stuff as part of what the user does. Okay, and then we say finalize USPS shipping transaction and note the tracking number. Enter the shipment information including the tracking number into our system. Then it comes to the system. Record shipment information including tracking number in the database. Send shipping confirmation email to customer. Now, one of the interesting things here is when I started to write this document, I was thinking that because we sent the confirmation to the customer and that we showed the customer on our use case diagram, that the customer was going to have some kind of action here. Well, the fact is that because we do this with email, we've kind of decoupled the action that the user, that the customer is going to have from the system. Yeah, they're going to open that email, but they're certainly not going to respond to it. Okay, so I've left that off. Okay, is that correct or incorrect? Well, I'm trying to emphasize the interaction between our system and the actors in kind of real time. So I've left that out as kind of an editorial decision. Could you show it? Yeah, I think you could. Okay, it doesn't have to complete though for the use case to end, and that's what I want to be clear about. In terms of our definition, is simply sending the email confirmation is enough action. We're not going to wait for it to be received. And then we confirm shipping transaction complete. Okay, that probably would be something that would be shown on the screen that the order shipper would see. And now this symbol, this isn't the only version of this symbol. This is used as a stop. This is a termination symbol. You sometimes will see them with a ring around them. Okay, I'll show you that in a little bit. Okay, so actually we could have gotten by with two swim lanes. Okay, order, shipper, and system. All right, so when you're doing an activity diagram for our class, if you don't have a lane for system, you're already in trouble. Okay, because the only thing that we're using for, at least in this way, is understanding to illustrate a scenario in a use case. So it's always going to include system, and it's going to include one or more swim lanes for actors. In this case, I drew two, thinking I was going to have some actions for both order shipper and customer, and then I decided from an editorial point of view I wasn't going to show the customer action of receiving the email. Okay, so one or more actors and system, and that's it. Those are the only swim lanes you get. Now, we haven't done a lot of fancy logic here, and that's okay. There isn't a lot of fancy logic in a basic scenario because of the fact that it is the happy day scenario. Okay? There's not a lot of if then else. We just show it going straight through. If we were to illustrate some other scenario, though, we would have some decisions to show. All right, let's go look at a couple of more things. All right, so let's shrink this guy, and let's take a look at that content from IBM Developer Works. And I'm going to try to make this content a little bit bigger. Doesn't seem to want to behave. I don't know why that doesn't work. Okay, I'm using the new Windows 10 Edge browser, and the key combination, well, let's try this key combination, see if it works. The key combination, oh, there we go. Different key combination works to make the content bigger. So activity diagrams, what they are and how to use them, is a really nice article here. More detail about the different parts of the different parts of the diagram, the different symbols and how they're used. Okay. They talk about some advanced things that you can do. All right. They talk about conditional threads. All right. And they talk about nested activity diagrams. That's not something that we're going to have to use, but it's kind of nice to see that that's there if we want to use it. And finally, they talk about, where are we? How this, here we have an activity diagram for the business use case proposal process. Okay, so this I think is a pretty good piece of writing about activity diagrams. It's not new. I think it's from back in 2004, but I think it's pretty compelling. Okay, let's look at a couple of other things that I want to show before we wrap up. Okay, here, let's come back to our PDFs. And I just want to show the different structures that we can use. Okay, so again, the circle, the filled in circle, is used for start. In this case, you'll see that I've used this filled in circle with a ring around it for stop. I guess I think this is the more proper termination symbol. Okay. In this case, we're just we're not saying what we're doing. We're just trying to show how the flow plumbing works. Okay. So we're saying we're going to start. We're going to do activity A and do activity B regardless. Okay. They're unconditional. Then we come into a branch. Okay. So in a branch, remember that we only take one flow path, one or the other. Now, typically people think of this as a choice of two, But in the activity diagramming language, it's so expressive that it can be one of however many you want. You just have to be able to connect them all to the diamond. It's easy to connect 3, but if you're a little clever, you can collect a lot more than 3. Okay? And as you see, I've got guard conditions on every path. Okay? I know that the illustration from the Hoffer book didn't show a guard condition on one path, but that was not good diagramming. Okay? So it looks like the decision here has to do with whether something is valid, and I've got is valid, not sure. So I'm describing 3 possibilities. Whatever happens at a branch, the possibilities described by the guard conditions need to be mutually exclusive. Okay? You can't go more than one way. It has to be clear which way you are going. All right? So in this case, depending upon what the validity of whatever, we go and do either Q or D or C. This is a classic merge. Okay? How do we know it's a merge? Well, flow is coming in from the top and the sides, and it's going out the bottom. Okay, that's pretty typical. There's also no guard condition coming out the bottom, so that makes it a merge. Right? Now, people who've had the opportunity to learn about programming flowcharts, and programming flowcharts has been around since the 1950s. Decisions in programming flowcharts were represented with diamonds, okay? But the decision was described inside the diamond, so we'd expand the diamond to make it large enough to pose the question, and then we would label the branches. So this is not the same thing. Did it grow out of that tradition? Yeah, I think it did. But this is different in a couple of ways. One, that the diamond is always a solid. It's never just an outline. 2, the diamond never gets any text in it. 3, the alternatives, the outflows are labeled, but they're labeled in a special way. You'll notice that these guard conditions are in square brackets. That's an important part of the syntax of the diagram. If you don't put the guard conditions into square brackets, they're not proper guard conditions. Okay? And so in this particular instance, we merge up. We always do E and then we stop. Okay? So this is the classic branch merge conditional logic. All right? So you're going to want to know how to do that. Now the other thing that I want to show is this idea of fork and join. Okay? Now forking and joining is a really modern way of looking at processing, because well, in the old days, and by the old days you can think of 1970s, 1980s, 1990s, okay, those kind of old days. We implemented a lot of system solutions, and we got a lot of the easy improvements. We made them, okay. And one of the things that we didn't do a lot of is we didn't create things where the workers could do things at the same time in parallel. Okay. A lot of, not all, but a lot of early system solutions just did a real good job of doing things in series. Do A, do B, do C, do D, do. So you'd never have this kind of situation that we see here where we're going to do things in parallel. Well, we got to a point where we got all the improvement we were going to get that way, and then we started to think about how could we get more improvement. And one particular technology that I was associated with led to this kind of stuff. And let me tell you what it was. We had a practice in um, document imaging and workflow. And historically, what would happen is one really good example was we did a project for HP where they had a warranty claims operation in California for printers, I think, maybe some other devices too. And they were not happy with how long it took to process a warranty claim. I think it maybe took maybe 60 days or something like that. And their customers weren't happy either. Because what would happen is a warranty claim would come in on paper and it would get placed in a some kind of a physical file, and then it would move from operation to operation in the claims process. And those just kind of add up. So it had added up to 30 days, 45 days, 60 days, which was too long. And what we realized at the time was the major reason that things were done, uh, well, there were two reasons that things were done in series. One is that there were only one copy of the documents. Two is that a linear workflow was easy to understand. It was hard for things to get mixed up, so there was a reliability to it. But what our system solution did is it really solved both of those problems. So when the document came in, we made an electronic image of it, and then we filed the original paper, and we never used it again unless we had to go back to it for some kind of backup. Um, and then once we did that, when all of our documents were electronic, then there was no reasons the things had to be done in a sequential order, um, because of the fact that only one operation could use the document at the same time, because once we had an electronic image, everybody could use it at the same time. And then we built a workflow application um, that controlled the logic of who could make what decisions. You know, certain decisions have to be made after other decisions, so they do have to be done in series. So the combination of things allowed us to take a process that was um, taking about 60 days on average and get it well under 30. I think we got it down to 20, 18, something like that. It was a big change. And so, how do you diagram that? Well, you diagram those kinds of solutions where you take things that had been done in series, one after the other in a serial way, and you do some of them in parallel. You can describe these with these four conjoined symbols. So this is a very popular approach to improving performance in organizations, and it's really great that activity diagrams have a way to express that. So this bar is both a fork symbol and a join symbol. And one of the things that you'll see when I go through the diagrammer is that the difference between those two symbols is just the attachment points on the little icon. Okay, so they don't look different. Okay, they behave differently. So if you pull out a fork instead of a join, you'll find, for instance, the fork has one attachment point on the top, multiple attachment points on the bottom. The join has multiple attachment points on the top, one attachment point on the bottom. So you just have to get the right symbol for what you're trying to do. They look the same when you look at them um, in the palette. Okay, they have a different name, but they look the same. So in this case, we're going to start, right? And then we're going to finish. We've got that stop symbol, okay? And we're always going to do A, and we're always going to do B. And now we're going to start to do things at the same time. So when we fork here, we are going to do all of these things. We're going to start to do Q and D and C all at the same time, okay? On this line of execution in the middle, there's only one thing to be done. So as soon as we do D, we're ready to wait for the synchronization with the other activities being done. So on the left line of execution, we can do Q, and when that's over, we can do R, and then we're waiting for synchronization. And on the right side, we can do C, and then we can do S, and then we're waiting for synchronization. And at this join symbol, think of this as a wait till we're all ready symbol, okay? So what happens here is we wait until 1 gets here, 2 gets here, the third one gets here, and then one line of execution starts up again, okay? Only when they all get there. Okay, so the join allows us to go, whereas the fork allows us to go from one line of execution to multiple lines of execution. The join allows us to synchronize and get back on one line of execution. All right. Now I'm showing 3 alternatives. There have to be. They're not alternatives. I'm showing 3 parallel lines of execution. Okay. There have to be at least 2. Could there be more? Yeah, as many as you can draw and understand. Okay. Could there be 2? Yeah. Could there be 5? Yeah. Could there be 500? Well, in theory, but that's a little hard to draw and understand, right? And to manage, right? So, but in terms of the logic of the symbols, you need at least 2, and it's between 2 and n. And then here, of course, we join up, we wait, we synchronize, we always do E, and then we're done. Okay? So, in the work that you're going to do with activity diagramming, you're going to be taking a scenario from a use case, and you're going to be creating an activity diagram. It's going to have 2 or more swim lanes. It's always going to have a swim lane for system. It's going to have a swim lane for at least 1 actor, perhaps more if there are more actors involved in that part of the use case. It's going to show a tennis-like back and forth between the system and 1 or more of the actors, and it's going to include either forks and joins, or it's going to include branches and merges if this is a scenario that is more complex than your basic scenario. Your basic scenario is going to show pretty much a top to bottom. The only thing that we probably can do in a basic scenario that would take branches and merges, some decision logic, would be some looping. And in fact, you'll see in the solution that I have to the skills practice that I do have a loop where I show some looping of the picking of the items on the order. And you might want to take a look at that too. Okay, so that's it. You're all ready to go. That's the lecture. I'm going to say bye until next time. Bye-bye.